So in the previous section, we introduced the Ising model, and then we showed what happened when we tried to coarse grain spatially by one of these decimation transformations that you've come to know and love. And what we found is that when we took one of those nodes, and I called that node sigma A, if we took that sigma A and considered on this lattice all the nodes that it was connected to, sigma 1, sigma 2, sigma 3, and sigma 4, if we considered all the nodes it was connected to and then averaged the standard Ising model probability distribution over those nodes, what we did was we took this nice form here, which we could see as just the product of node pairs. We could imagine this as one gigantic network with edges between nodes, and the edges told you which pairs to multiply together. What we found is that this actually changed and became much messier. And in particular, if we just wrote down the part of the probability distribution that we were tracing out with sigma A, we found that we induced a new set of couplings. We had a coupling, we'll call that S2, between all pairs connected to sigma A. And that S2 was equal to 1 over 8 log cosh 4 beta. And then we also induced this very strange triplet term, which I'll call S4. And S4 actually connected in a synergistic fashion sigma 1, sigma 2, sigma 3, and sigma 4. And in fact, S4 was equal to S2 minus 1/2 log cosh 2 beta.